Iceland has declared a state of emergency, warning of an imminent volcanic eruption. People have already evacuated a small fishing town there, and the country's southwestern peninsula has experienced hundreds of earthquakes in recent days.
Shocking news from Iceland. The serene land of fire and ice is on the brink of disaster. Unprecedented seismic activity has experts on edge as hundreds of earthquakes rattle the earth.
Oh my God!
But what if this is just the beginning?
Iceland this morning, scientists say an active volcano in the country's southwest could erupt within hours.
Brace yourself as we delve into the shocking reality of a potential apocalyptic earthquake in Iceland. The ground quakes and the countdown to devastation has begun. Iceland, a land of fire and ice, sits atop the mid-Atlantic ridge, a monumental feature of our planet's geology. This ridge is not just a geographical wonder, it's a dynamic boundary where two of Earth's major tectonic plates, the Eurasian and North American plates, diverge. This divergence is a slow but powerful process, where the plates move apart at a rate of approximately 2.5 centimeters per year, roughly the same pace at which human fingernails grow. This might seem slow, but in geological terms, it's remarkably fast, leading to significant changes over centuries and millennia. But what if this gradual divergence suddenly accelerates? Could Iceland, this serene island of natural beauty, be on the brink of a catastrophic apocalyptic-scale earthquake? Stick with us as we explore the exact possibility of such a seismic event. At the heart of Iceland's geological story is the mantle plume that lies beneath it. A mantle plume is a column of hot, solid material that rises from deep within the Earth's mantle. When it reaches the crust, the heat and pressure cause the rock to melt, forming magma. This magma, less dense than the surrounding rock, rises through the crust and can lead to volcanic eruptions when it reaches the surface. The presence of this mantle plume beneath Iceland is what makes the island one of the most volcanically active places on Earth. But what does this mean for Iceland and its landscape? Consider this. When you think of a volcano, you might imagine a single conical mountain erupting lava and ash. However, in Iceland, the reality is far more complex and fascinating. The interaction between the mantle plume and the diverging tectonic plates has created a unique geological environment. This environment is characterized by an array of volcanic systems, each consisting of a central volcano and a network of fissures extending outwards. These fissures are cracks in the Earth's surface from which lava can erupt, often creating spectacular lava fields rather than traditional volcanic cones. Iceland's volcanic history is as rich as it is long. The island has been shaped and reshaped by countless eruptions over thousands of years. One of the most famous historical eruptions occurred in 1783 from the Laki fissure system. This eruption was not only massive in scale, spewing enormous volumes of lava and ash, but it also had profound effects far beyond Iceland. The ash cloud spread over much of the northern hemisphere, causing significant climate anomalies and leading to crop failures and famine in Europe. It was an eruption that changed the course of history, illustrating the far-reaching impacts of Iceland's volcanic activity. But why should we pay attention to Iceland's volcanoes? Well, the interplay between the tectonic plates and the mantle plume beneath Iceland is not just a story of fire and brimstone, it's a tale of creation and transformation. As the plates move apart and magma rises to the surface, new land is literally being formed. This process can be observed in the stunning landscapes of Iceland, where new volcanic rock cools and solidifies, gradually being colonized by plants and animals. It's a process of continuous renewal, where destruction is followed by creation, and the land is ever-changing. Yet beneath this serene process lies a terrifying revelation. The Reykjanes Peninsula, a rugged strip of land near Iceland's capital, Reykjavik, has become the epicenter of a seismic crisis that could culminate in one of the most significant volcanic events in recent history. For weeks, the ground has been trembling non-stop, with hundreds of earthquakes rattling the region daily. But what does this mean? Are we on the brink of witnessing a volcanic spectacle of unprecedented scale? Earthquakes are often harbingers of volcanic activity, acting as pressure valves releasing the stress accumulated in the Earth's crust. As magma moves and intrudes into new areas underground, it fractures the rock, causing earthquakes. This seismic activity is a crucial indicator for geologists and volcanologists who analyze the patterns and depths of these tremors to predict volcanic eruptions. But how massive, you might wonder? The scale of the impending eruption could be colossal. Iceland's authorities are on high alert, with a state of emergency declared and nearly 4,000 people forced to flee their homes. The Icelandic Meteorological Office warns of a considerable risk of eruption near Reykjavik. The ground beneath their feet is a battleground of tectonic forces, with magma building up just 3 miles underground. The movement of magma is typically monitored using a combination of seismic activity readings, ground deformation measurements, and gas emissions analysis. Seismographs pick up the tremors caused by the movement of magma, while sophisticated satellite technology measures even the slightest changes in the Earth's surface that could indicate rising magma levels. One of the most alarming aspects of this situation is the depth and frequency of these earthquakes. The seismic activity is not just occurring on the surface, but is indicative of deeper movements within the Earth's crust. This suggests that magma is moving and intruding into new areas underground, causing the rock to fracture and resulting in these earthquakes. All signs appear to be pointing to significant and potentially explosive buildup of volcanic pressure, which poses a serious threat to both the immediate area and regions beyond due to the unpredictable nature of subterranean magma movements. The very ground we stand on could turn into an explosive gateway for volcanic fury. Recently, there has been a decrease in earthquake frequency, but rather than providing relief, this has only heightened the sense of impending doom. Dr. Margaret Hartley, a lecturer in earth sciences at Manchester University, warns that this could indicate a new phase of magma intrusion. In other words, the volcano is not calming down, it's gearing up for something bigger. But what could be bigger than the continuous tremors that have already caused roads to crack and homes to shake? The answer is both fascinating and horrifying. An eruption at Fagradalsfjall, the likely site of the volcanic activity, could unleash a torrent of lava, capable of obliterating everything in its path. Dr. Phil Collins from Brunel University, London, paints a grim picture, suggesting significant lava flows that could destroy homes and alter the landscape permanently. And while the eruption might not produce the disruptive ash clouds of the infamous 2010 Eyjafjallajökull eruption, the threat to local infrastructure and the environment is real and imminent. The question on everyone's mind: when will the volcano erupt? But the answer is chillingly uncertain. The IMO describes the situation as hovering in a precarious balance, a magma intrusion teetering on the edge of eruption. And the situation in Grindavik, a village near the epicenter of the seismic activity, is particularly dire. In response to the escalating threat, the village has undergone a complete evacuation, a clear testament to the severity of the situation. Imagine an entire town abandoned as the earth beneath it threatens to burst open. But why is this movement of magma causing such alarm? Volcanic eruptions can vary greatly in size, duration, and type of volcanic activity. In an effusive eruption, lava flows could spread across the landscape, destroying everything in their path. This type of eruption, while less explosive, can still have devastating effects on infrastructure, such as roads, bridges, and buildings. The lava can also cover large areas of agricultural land, rendering it unusable for years to come. But what makes this situation even more unpredictable? The fact that an eruption could involve a combination of both effusive and explosive activities, compounding the potential impacts. The 2010 eruption of Eyjafjallajökull is a prime example. Eyjafjallajökull, a glacier-covered stratovolcano located in southern Iceland, erupted in April 2010 after nearly 2 centuries of dormancy. The eruption was characterized by explosive activity that sent a massive ash cloud into the atmosphere. This ash cloud, composed of fine, abrasive particles, posed a significant threat to aircraft, as these particles can damage jet engines and other critical aircraft systems. As a result, there was widespread disruption to air travel across Europe and beyond. The scale of the air travel disruption was unprecedented. Over an 8-day period, the ash cloud led to the closure of large swaths of European airspace, grounding approximately 100,000 flights and affecting an estimated 10 million passengers. The economic impact was staggering, with the airline industry suffering losses estimated at around 1.7 billion euros. The disruption also had a ripple effect on the global economy, affecting trade, tourism, and business. But the eruption also had significant environmental and health implications. The ash fallout affected local agriculture, contaminating water sources and pastures. In areas close to the volcano, the ash accumulation posed a health hazard, particularly for those with respiratory conditions. The fine ash particles, when inhaled, could cause respiratory problems and exacerbate existing health issues. The environmental fallout was also evident in the aftermath of the 1783 to 1784 Laki eruption, one of the most catastrophic volcanic events in recorded history. The Laki eruption, which occurred in the Grímsvötn volcanic system in Iceland, was not just a single explosive event, but a series of fissure eruptions that lasted for 8 months. The scale of this eruption was immense, with an estimated 14 cubic kilometers of basalt lava and enormous quantities of volcanic gases being released into the atmosphere. The lava flows destroyed vast areas of farmland, leading to a severe famine that claimed the lives of approximately a quarter of Iceland's population. But one of the most significant impacts was the formation of a thick, poisonous haze that spread across Iceland and beyond. This haze, composed of sulfur dioxide and other volcanic gases, caused a drastic drop in air quality. In Iceland, it led to what is known as the moduhardindin, or mist hardships. The population suffered from severe respiratory problems, and the contaminated air and water led to the death of livestock, exacerbating the famine. But the impact of the Laki eruption was not confined to Iceland. The sulfur dioxide emitted into the atmosphere formed sulfuric acid aerosols, which spread across the northern hemisphere. This led to one of the most significant environmental changes of the time, a phenomenon known as volcanic winter. The aerosols reflected sunlight away from the Earth, causing temperatures to drop globally. In the years following the eruption, Europe and North America experienced abnormally cold winters, crop failures, and food shortages. The year without a summer in 1784 is often attributed to the after effects of the Laki eruption. The Laki eruption also had a significant impact on human health beyond Iceland. The sulfuric acid aerosols in the atmosphere led to acid rain, which had harmful effects on vegetation, soil, and water sources. In Britain, the summer of 1783 was marked by reports of thick fog, respiratory problems, and an increase in mortality rates. The health effects were not limited to respiratory issues. The contaminated air and water sources led to a range of health problems, including skin diseases and gastrointestinal disorders. In the years following an eruption, Iceland's volcanic soil undergoes a slow process of regeneration. While the initial volcanic ash is rich in nutrients, it takes time for the land to regain its fertility. The volcanic soil, once barren, gradually becomes fertile ground for new plant life. Pioneer species, such as mosses and lichens, are often the first to establish themselves, followed by hardy grasses and shrubs. Over time, more complex vegetation communities take root, supporting a variety of wildlife. However, the long-term environmental consequences aren't limited to land. The introduction of volcanic ash and chemicals into water bodies can have lasting effects on aquatic ecosystems. Changes in water chemistry, such as altered pH levels, can impact fish populations and aquatic plants. The slow recovery of aquatic ecosystems depends on factors like water flow rates, water quality, and the availability of nutrients. Amid the seismic shudders shaking Iceland, two sites emerge as focal points of both concern and fascination: the Blue Lagoon and the Svartsengi geothermal power plant. The Blue Lagoon, a geothermal spa renowned for its milky blue waters and healing properties, is not just a symbol of Iceland's natural beauty, but also a cornerstone of its tourism industry. Each year, it draws in hundreds of thousands of visitors, eager to immerse themselves in its warm, mineral-rich waters. But have you ever wondered where this magical water comes from? The answer lies in the Svartsengi plant, a geothermal power facility that not only supplies electricity and hot water to the region, but also feeds the Blue Lagoon. The potential eruption poses a significant threat to these iconic locations. Imagine the Blue Lagoon, a serene oasis now on the brink of being engulfed by volcanic activity. The impact would be twofold: a devastating blow to Iceland's tourism and a critical disruption in its energy supply. The Svartsengi plant is not just a power generator, it's a lifeline for the surrounding communities, providing essential services that are now at risk. But what measures are being taken to protect these vital sites? Recognizing the catastrophic potential of lava flows reaching these areas, the authorities have embarked on an ambitious project, constructing protective barriers. These barriers are meticulously engineered to divert and contain lava flows should the worst happen. But is it enough? The challenge is immense. Lava flows, with their immense heat and unstoppable momentum, are notoriously difficult to control. The barriers must be strong enough to withstand the intense pressure and high temperatures. The task is not just about building walls, it's about understanding the unpredictable nature of volcanic eruptions and preparing for every possible scenario. Future volcanic risks in Iceland are a matter of significant concern. The island's geological history is riddled with eruptions of varying magnitudes, and the potential for large-scale volcanic events remains ever-present. While Iceland has a robust system of monitoring volcanoes and seismic activity, predicting eruptions with pinpoint accuracy remains a formidable challenge. Evacuation plans, emergency response strategies, and community preparedness are essential aspects of mitigating these risks. But while the future holds uncertainties, advancements in technology are providing valuable tools to improve volcanic predictions and safety measures in Iceland. One such advancement is the use of remote sensing and satellite technology. These tools enable scientists to monitor volcanic activity from afar, providing real-time data on ground deformation, gas emissions, and other critical indicators. This information allows for more accurate eruption forecasts and early warning systems, which are essential for minimizing the impact on communities and infrastructure. Ground-based monitoring networks are another crucial component of Iceland's volcanic safety measures. These networks consist of seismometers, GPS stations, and gas sensors strategically placed around active volcanoes. They continuously collect data and transmit it to monitoring centers, where scientists can analyze the information and detect any signs of impending eruptions. These networks not only improve prediction accuracy, but also help guide evacuation and emergency response efforts. Additionally, Iceland's collaboration with international organizations, such as the Icelandic Meteorological Office and the University of Iceland's Institute of Earth Sciences, enhances its volcanic monitoring and research capabilities. These partnerships contribute to a global understanding of volcanic processes and hazards, benefiting not only Iceland, but also regions around the world susceptible to volcanic activity. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen. You won't believe it.